Welcome everyone. So today on Twitch, we are going to have a very good time with Frederick over here. So we're going to be talking about conprof and continuous profiling using polar signals. So this should be a pretty good time. I've done just a little bit of setup beforehand, so that way we don't have to spend a bunch of time watching me fight NixOS and everything, but should be a lot of fun. So Frederick, do you want to maybe introduce yourself a little bit and talk about yourself, polar signals, and just give folks a little bit of background context? That'd be great.
Yeah, absolutely. First of all, thanks for having me here, Matt. So I'm Frederick. Some of you may know me. I've been doing like observability and monitoring for the past 5 years. I actually originally joined CoreOS back then. I joined the Prometheus team there, and actually that's how Matt and I met. Matt and I both were on the Prometheus team for a while. I still am. I think Matt recently decided not to anymore. I'm super active in the Kubernetes community, and right, right around half a year ago, I founded Polar Signals, and uh, having worked on Prometheus so much, one of the things that was always kind of frustrating, and I felt like we could do better, was uh, how we profile our applications. And many of you may be familiar with like memory leaks or stuff like that, where it's I'm people are saying I'm a bit quiet. Maybe it's
Oh,
a bit better.
I just bumped you on my
Oh,
end too. So one sec. Let me turn it back down just in case, because yours is probably better than whatever OBS is doing. Okay, try now.
okay. Hopefully that's better now.
Yeah, it sounds better to me too. So like looking at the levels, it looks good.
Okay, great. Um, like when you have a memory leak in your application, for example, it's so hard to figure out what caused that, because most of the time you only realize that there's a memory leak when your application has already died, right? And so it's extremely hard to get a memory profile just from that point, from just where just about where it died. Um, so yeah, continuous profiling is essentially about always doing profiling, and we use kind of sampling profiling techniques, which thankfully, like the Go runtime has out of the box. So we use sampling profiling to essentially have extremely low overhead in profiling, so that we can always do this, right? Um, so that we can just take small amounts of data all the time, so that we always have the data at hand when we need to, for example, for a memory leak. But a lot of people find this super useful also for latency spikes, where for whatever reason your CPU spikes, for example, and your requests are taking long. And actually, as a matter of fact, this is where people have been um, seeing this product work the best, is just in plain resource optimizations, right? We're working with a couple of people, for example, who work on databases, and it's just the core value of databases is that they're fast and use as little resources as possible, right? And so that's a really great combination of kind of people trying to always deliver on performance, and that's where continuous profiling really shines. So hopefully we can find some cool opportunities in your home lab today as well.
Right on. Yeah, so I've got one initial thing in mind. So I am running my on my router. I'm running my home built IPv6 neighbor discovery router advertisement daemon that I know exposes pprof. So we've got at least one target, if nothing else. But I suspect there are other things too, like perhaps like core DNS or let's see here. So like core DNS or maybe some of the Prometheus explorers I'm running or Prometheus itself. Those could all be cool things to do. And of course, we can also scrape conprof with conprof, right?
Absolutely.
So
That's the default configuration.
sweet, should be a good time. So probably what we're going to do here first is I think I'll go through what I have done so far effectively to get conprof running on NixOS. So for those who've been in the stream for a little bit, I use NixOS as my operating system on my router and my server, and it's nice because it's kind of like a declarative Linux. But in order to actually get things working and packaged on NixOS, it's sometimes a non-trivial TM amount of work. So I did a little bit of prep beforehand. Matthias says continuously profiling the router is just what I expected. Yeah, exactly. So I guess just to go through this really quick, if you've been on the stream before, you've probably seen my home lab repo and stuff. So I'm actually SSH'd into my server. I've got SSHFS open here in VS Code, and let's see here. So I'll hop on the server too. Oh, that's gonna be okay. So we got our panes. Let's do this instead. Yeah. So I have system status conprof. Yep, I've already got conprof running. So I actually wrote a NixOS small little package and module to get this working, and I'll explain exactly what that is. So in my NixOS configuration here, if I go to the base configuration for my server, we import a couple of things here. So first, we add an overlay for a package called conprof that we are defining here in this lib packages directory. This is because conprof at the moment is not packaged in the upstream Nix packages repository. And while I could do that, it was way less work just to get this up and running this way. And ultimately, at the moment, Frederick and I had discussed conprof does not have any tags at the moment. So I think generally they prefer to have tagged software in there. So possibly if there's going to be like a 010 coming, we could put it in there then. But for now, we're just building off some commit at master that I know works. So that's totally fine. So we have the overlay, which allows the package to be used. And we actually have to define a NixOS module as well. So this is what importing this lib modules does. And when I scroll down and look at the configuration, you'll see here, so services conprof enable equals true. And we just have the empty configuration file right now. So this is where the magic of NixOS happens. Like, once this is upstream in Nix packages with the package and the module, you on your NixOS machine, assuming you're running a latest version of Nix packages, you do services.conprof.enable, and it installs it and configures the systemd unit and does all of that, which is pretty cool. So the way that fits together is we have this package here. The package name is called conprof. We are defining it at this git tag version. It fetches the source code from GitHub at this revision with this hash checksum. The dependencies have this checksum. Then we give it a little bit of metadata, like this is the repo is called conprof. It's Apache 2 license. And then there's a little bit of work here actually to get this packaged. So by default, the build go module like helper here in NixOS will run all the tests. And I noticed that on NixOS, like some of these things are not installed by default, like GraphViz, and I think there's a test that uses Docker as well. So yeah. I said it right now so that it doesn't run the tests, but that's okay. But perhaps this is something that we could consider sending as like a change to conprof ourselves, is making it so that like if Docker isn't installed, it skips the Docker tests or something. Like basically what this is doing is it's running go test // and it'll fail. So I had to add this do check equals false. But yeah. It is worth noting that conprof does have a dependency on GraphViz for rendering SVGs. So I do actually add this as a native build input, which allows us to have the dependency for GraphViz as part of the conprof package here. Frederick, do you have something to say, or like I just did I skip over something?
No, you got everything.
Okay, cool. So this is kind of temporary at the moment. We're going to actually add a tagged package for this at some point, and we'll get it upstream, no problem. So the module, basically the way you define a module here is we options.services.conprof, and this is a new object here. Let's see here. So we add make enable. So this means that, when this is true, it actually enables conprof. Right now we have an option that defines the verbatim configuration, just a file. And this is fine. Generally, the proper NixOS or Nix way to do this would be to use Nix attributes, but that's a little more work than I want to deal with right now. I've done this elsewhere, but today we're just going to write raw YAML. It's fine. And then we can also select which package to use. In this case, we have to import the package from out of tree. And basically what this is doing is when you enable this, it's going to create a user on your NixOS system called conprof. It's going to give it a home directory of varlib conprof, and this is all hard-coded right now, but we could make this different. And this is where the conprof daemon is going to store its data, its backing time series database and such. We create a systemd unit, make sure it comes online after the network is online, because conprof reaches out over the network, so it seems like something that might be kind of important. And then just a couple of systemd things like limiting the number of processes or the number of open files. And we concatenate together. This is a little snippet I stole from the Prometheus module, I believe. Concatenate together these command line arguments and run them. So when I was setting this up, Frederick, I saw conprof all, I think this was from the README, conprof all with a config file, an HTTP address, and then the TSDB path. But I believe the polar signals integration uses a slightly different syntax, right?
Right. We want to send all of this data to polar signals, so we're going to just use the sampler subcommand instead of all. So the all subcommand essentially runs the whole thing, the TSDB, the scraper, the yeah, just everything in one process, right? But with polar signals, you basically, part of our offering is that you don't have to care about the storage part, right? And we add a couple of additional features on top. And so we're just gonna use that and send the data to polar signals. Yeah.
Cool. So the way this will work then is there will be no local storage at all. It sends all of the profiles directly to polar signals, and then you don't have to worry about your local storage.
Right.
Cool. Right on. So we'll still need the configuration file. This is where we define like our scrape targets. We'll still need the HTTP address. This is where the web UI is served. I know conprof has kind of like a primitive sort of web UI, and clearly polar signals is like effectively a nicer interface with some added features on top of that, right? Does
Right.
some Go ahead, sorry.
Go ahead. I was just going to say, like, there are a couple of things that also that we're mixing on top of continuous profiling that just don't necessarily fit into conprof. So like something that I could show later, maybe one of the things that we're working on right now is also kind of generating and extracting metrics out of profiles. And that's just something that we didn't want to put into conprof necessarily because it's more opinionated than we want the open source project to be. So those are kind of part of our offering, where you could do these things yourself with a Prometheus server next to it, for example. But as part of Polar Signals, we kind of offer all of it as kind of a cohesive bundle.
Right on. So as far as like interfaces for conprof profiles at this point, does Grafana have any sort of like built-in support for conprof yet?
So we do have a Grafana. Someone did start something, but I'm actually not sure how up to date it is. To be honest, there is something, but I don't know if it works right now.
Right on. Okay. So cool. So as you've mentioned here, we need to change the command line and everything. And actually, what we're going to do today is I'm going to generate a temporary credential, which clearly everybody on Twitch will be able to see. Actually, I guess I could hide it, but is it worth hiding? I mean, I guess otherwise
Probably not.
it's probably not worth.
We can just remove it afterwards.
Okay, sounds good. So what we're going to do here now is we're actually going to work on setting up conprof in order to integrate with the polar signals continuous profiler, which should be pretty fun. So I was invited to the closed beta because I'm a very important person in the Go community. I'm kidding. Frederick and I talked about this previously, and he reached out to me pretty early. So I'm excited to play with this. It'll be a good time. So I'm just going to create a token here. Again, clearly Twitch chat can see this. So, while you could do silly things with this, I would encourage you not to, and it's going to be deleted anyway. So don't use this for your profiles. Right. I didn't give it a name. But we have a token now. It's this pretty long string. Good luck typing that out verbatim. That would be a pain in the ass. And then now we have all of this. Let's see here. So it's built right into the command line, right?
Yeah.
So we need to transliterate this into we need to put this into the flags syntax I had defined elsewhere. Okay. So at the moment, so instead of running all, we're going to run the sampler. We have, so you can define targets on the command line as well as the config file?
Yeah, this is just something to get people started really quickly. If you don't want to write out the entire YAML configuration, you can just pass in a target. But I think for us, it could be interesting to look at the config.
Definitely, yeah. And I actually set it up so that, right now we're ready to start writing the configuration and everything too. So I think we'll probably leave that out. Should I do the log level debug? Would that be useful?
I don't think it's particularly interesting.
Okay. And then, of course, this store line, this is necessary. So store equals polar signals, gRPC. Let's see here. Yeah. So config file, HTTP address, and then instead of having the TSDB, we're going to have all of this. So I could put this in this is actually two things here.
Yeah.
So that's quoted. Are the quotes here significant? Or I guess I'm trying to...
I don't think so.
Okay.
I think you can skip them.
Cool. Did I miss a quote? Yes, I did. So now we've got the config file, the HTTP address, the store, grpc.polarsignals.com 443, and then the bearer token. And then this should allow us to pass samples to up there. Let's see here. Right. So do we want to define a target now in the, let's see, I'll close this. Do we want to define a target for this? Right? Like, could we define Could we define conprof itself as a target in the YAML right now? Do we want to do that?
Yeah, we can do that. If you want to head to the conprof repo, you can check out an example configuration.
Sure. Let's see here. So
There
conprof.
was a question in the chat actually about whether conprof is like a self-serve version of Google Cloud Profiler.
Mhm.
So it's a little bit similar, but the Google Cloud Profiler actually only shows you merged versions of things, whereas with conprof you can actually look at every single sample. And so we found that particularly useful to investigate certain points in time, right? Like as I in the very beginning, I was talking about memory leaks, and a merged representation is not particularly useful when you're when you know like this was the point in time just before my process crashed, right? And so we've focused on actually storing every single profile, whereas Google Cloud Profiler essentially tries to merge them a lot. Which makes sense for like storage capacity, and it's a free product if I remember correctly. So I get all of their decisions, and they're not necessarily bad. We're just trying to yeah, give people a little bit more value.
Right on. So I found this example here, and I remember taking a look at this previously. So this clearly is derived from the Prometheus config syntax. The scrape configs like very, very similar, even though it's the scrape interval and everything. So I guess my one question here, looking at this immediately, is I know I watched your presentation last night, by the way, from the Kinvolk CNCF meetup, and having done Go for a while, like I'm aware there are different profile types as well. So for example, you've got your CPU profile, your heap, blocking, mutex, all of that. So will
Yeah.
will conprof by default gather all of those types of profiles every 1 minute here?
Yeah, it'll attempt to get all of them. Correct.
Interesting. So for the CPU profile, for example, it usually has to run over like a period of time. Like I guess when I'm doing it locally, I'll run like 30 seconds or a minute. So how long do you gather the CPU profile for in this case?
That's what it defaults to as well.
Uh-huh.
But you can configure it to whatever you want. You can there's actually a question that's really relevant right now in the chat as well, which is does conprof get its traces from the pprof API from the kernel, and if so, what's the overhead to run it? So pprof itself is not sorry, yeah, it is pprof format. And anything that is pprof format works here. Go has these profilers built in, but they do not go down into the kernel. So essentially, it stops at the syscall level. And in terms of the overhead that it runs, that it requires, it really depends on how often and at what uh, like frequency you sample. So as I just said, uh, you can configure all of that. So in this case, we're going to sample once a minute for 30 seconds in terms of the CPU profile, but you can make that every 10 seconds for half a second, for example. And so you can end up actually playing with the amount of overhead that you're willing to pay. Most of the people that we've worked with so far cannot even tell the difference. So whether you turn it on or off, you can't even see it in your like cumulative CPU graphs, for example. And then there's another question by Jimmy. The kernel has a pprof API question. Are you confusing with perf by chance? So actually, there's something really cool here. You can convert perf traces to pprof, and we're still in the kind of investigation phase for this, but we're looking into how we could potentially make something work there, so that you could profile an entire machine, for example, or actually go deeper than the syscall level. This is still in investigation, but this is something that a lot of people have been asking about. So maybe one day we'll get something useful out of the kernel as well.
Very cool. Really quick, large data bank. Thank you for the 10 months. I appreciate that. 60 seconds of profile every 60 seconds. So yeah, literally true continuous profiling. So Frederick, actually something cool. I think I may have seen this in the README or something as well. So I imagine, myself, I'm a Go developer. I imagine lots of people here, just knowing my community, are probably Go developers as well. So we're used to pprof being native, but I remembered seeing there was like a Rust crate for exposing pprof, and there's probably other, I guess, bindings for other languages as well. So although I imagine this is probably mostly geared towards, Go CNCF folks because it's a very popular language in CNCF, people are probably using all kinds of languages with this, right?
Yeah, so for the Polar Signals product right now, we officially are only supporting Go, but in theory, Polar Signals is compatible with any pprof formatted profile, which is exactly why if we convert a perf trace to pprof, you can ingest that into Polar Signals. But there are open source libraries for Rust, there are for Python, there are for the JVM. I don't know the exhaustive list anymore, but there are a lot of them out there already. So it should be fairly trivial to continue to add support, but we want to make sure that we do a good job for each of them. So we don't just want to kind of claim there's support for everything, but then one runtime is really poorly supported and one's really great. Yeah.
Absolutely. Let's see here. So I think at this point I'm gonna just apply the configuration here because I think that it'd be cool to see this working. And we got some more questions in chat as well. So I am not the expert here by any means. So if Frederick would like to field questions, he is welcome to. I can, but as far as the in-depth of like pprof and stuff, like I understand like what pprof gives me, but as far as the internals and everything, I frankly have no idea. So
Yeah, there's a great question that I frankly don't actually know the answer to. Going deeper requires frame pointers, but compilers skip it. So what's your approach? Actually, I'm not 100% sure. As I said, we're still in a really early investigation phase here. So far, the extent of what we've done in this investigation is essentially take a perf trace and then use a tool that Google wrote that literally converts perf to pprof and written that to Polar Signals. And we could see some results with this, but it's certainly a little rough. Yeah.
fair enough. So I just ran the NixOS rebuild switch, and we actually have the new configuration here applied. So we can see the systemctl cat. I love this command, by the way. It took me a long time, but if I want to see the output of a unit, this is very useful, especially with NixOS because you're generating all of this like through some kind of magic. So we can tell here we are running the conprof sampler with our config file, HTTP address, the Polar Signals gRPC store, and then the bearer token. So let's take a look at the config really quick. I'm just curious how this looks. I think I got it right, but yep. So we should just be scraping conprof locally, and I believe now conprof. Is it running? It seems to be running. Yeah. Okay. Receive signal terminated. Right. So I think that right now we are profiling. So let's see here. So localhost 10902. Oh, it's not localhost. Actually, it's running on my server. So, oops.
You won't see the UI in this actually. So the sampler, all the sampler does is it has only the scrape code and then sends it off via gRPC. So you're gonna have to go to Proto Signals for this. Yeah.
I see. Okay. So does the sampler still expose Prometheus metrics though?
It does. Yes.
Okay. So there's no web UI, but there is. Yeah. Okay. Cool. Because occasionally it's useful just to poke at this too. Cool. Yeah. So if I refresh this now, let's see here. So we have my home lab project. We set up collections now. Browse profiles. Do we have anything yet?
Looks like it. You've got some.
Select profile. Interesting. Okay. So what would be useful to look at? Perhaps allocations, right? That could be fun. Search. Oh, did I?
Yeah.
So I need to.
You can just remove that.
Yep. So allocation profiles, search, do it. Sweet. So we can see here we've got 434 UTC, 435 UTC, job equals conprof, instance equals localhost. Excellent. Very cool. So let's take a look at the first one, I suppose. I did briefly set this up a couple weeks ago, and I had tested it with a couple of my things, but I kind of wanted to start from scratch today. So we can see here we've got the nice SVG and everything, so we can actually see this is conprof profiling itself every minute and giving us this SVG output, which is pretty neat. Something else that's really cool, actually, is I know the Polar Signals folks, they have, so what is it, share.polarsignals.com?
Yeah.
This is something I want to shout out really quick because I think this is a great idea. If you have a pprof profile, typically the way we will share these outputs, like, and I do this all the time at work and everything, is I will take the SVG and upload that, or make a PNG and upload that. But with this share.polarsignals.com, you can actually upload your pprof profile directly and then just share it in a nice web UI. So this is pretty sick, and I love this idea.
There's actually something really cool also. If you go back to the continuous profiling, you can actually create a share from your continuously profiled.
Oh, nice. Yeah.
So you can just hit that share link and
Yeah. Description, single profile of type Alex. Okay, nice little auto-generated description here. So we can share this with the Twitch chat so they can see what's going on my server. Cool. Very neat. I like that idea. And this, I assume, yes, you can view all the different parts, like the allocation, the objects, or the in use. Cool. Or you can download it yourself for processing with your own utilities.
yeah.
Wait, this is sick. Yeah, this is sick. I know. I love this idea. So if we want to take a look here, yeah, so something that's interesting to me is like this SVG type view, like this is very much what I'm used to, but I am aware that pprof has other views as well. And for example, you support let's see here. So we have, we're already on the graph, right? We have the top view. So this shows you, like, for example, like the tabular format. This is something that if you've ever used GoTool pprof on the command line, I think you type like top 10 or something, you'll get like an output like this, but clearly this is much more nicely formatted. Definitely less visual, but as far as looking at the analytics themselves, you can see like, the compressed flight writer is allocating the most memory over time or something. It's 25.74% of the cumulative. But also the Icicle graph. So what's the difference between a flame graph and an Icicle graph? Is this your branded spin on a flame graph?
It actually, I did not come up with this. So
I don't believe you.
You can Google Icicle graph.
Yeah.
Brandon Gregg actually does reference this name as kind of the upside down version. The one that's actually part of the pprof tooling itself as well is not technically a flame graph. It's an Icicle graph. So
Interesting.
when we read this, we were like, we could not have kind of like had a better coincidence happen here, right? Like with our polar branding Icicle graph.
Yeah, so that was going to be my guess, actually, is that you were perhaps inspired the name of the company based on this Icicle graph concept, but no, interesting. It's just a coincidence.
No, this was entirely coincidental.
Yeah.
It happened, actually the rename of this happened just like 2 days before we launched. Yeah.
Very cool. Yes, this is pretty sick. So with this, like with the flame graph, Icicle graph style, like, so my understanding here is that you've got the root span, for example, and then the relative width of each of these is like how much time, like, relative to the other ones they're taking up. And then you've got this stack like this. So this would indicate perhaps that the main new sampler, let's see here, we've got YAML. Oh, this is like a call stack, right? So this is all the YAML code
Exactly.
calling into each other. Right, okay. Neat. So another one I like to look at is let's see here, so allocated space. Oh, this is still the Icicle graph, right? See, it's kind of funny because, like, intuitively, I'm sure I could like train myself to like intuit this more, but for me, just like I always like, I love this view because you can just look for the big red hotspots. Like, for example, this jumps to your mind immediately, like the flight writer. Something I've had a pretty funny story with profiling one time. We were getting out of memory problems at a service at DigitalOcean, and I started looking at the pprof graphs, and it's like, oh, you are allocating 50 gigabytes of heap. Like, you've allocated 50 gigabytes of heap in the past 10 minutes. And it's like, how is that even possible? So we were doing a netlink system call that should have been done once at startup and then memoized for the rest of the application. We were doing this system call on every gRPC request for every element within an array within that request. So we were doing millions and millions of system calls to look up the same information over and over and over again, and just throwing away all that memory. And it was just, that's clearly a big red hotspot on your graph.
Yeah.
Pretty funny.
Yeah, I think all of these representations have their place, right?
Mm-hmm.
For example, one thing that you don't see in the Icicle graph is you can see when the graph goes together again, right? They're always distinct. So you can tell kind of what the best thing to optimize for is, like, for example, the thing that you pointed out that with the YAML, because it's kind of a straight line all the way to the bottom, it means that the thing at the very bottom is the thing that you need to optimize here.
I see.
Because
Okay.
everything else doesn't add any more overhead to this, but the thing at the very bottom is the thing that's most going to have most impact.
I see. Okay, with that knowledge in mind, that definitely helps me understand how to read this a lot better. So, for example, so the JSON stuff, there's a sync map in here. Interesting, because I know like JSON is like very much like heavily reflection based and everything. So I would expect it to see reflect at the bottom here instead of like sync map. But, huh?
Yeah, that's interesting. I'm not sure.
Yeah.
The sync map could be a thing about the what is this anyways? Runtime main. This might be part of the discovery.
Most likely. Click into JSON.type. Let's see here. Right. So sync map loader store. Huh. Yeah, I wouldn't expect. Oh, this is the actually setting up the JSON runtime do init. Interesting. So serializer new codec factory. I have no idea. Is this the Go runtime or is this something in? I have no idea.
Yeah, this should be Go runtime. Yeah.
Interesting.
No, this is a Kubernetes thing.
Is
So
that
we
okay?
have Kubernetes service discovery, and yeah, this is like stuff that gets automatically set up through init methods. Yeah.
I see. I was gonna refresh here. We probably got a bunch more profiles now. So browse. Last hour search. Failed. Right. So let's take a look at the CPU this time. That's another fun one. So we can see here we're generating these profiles. We've got a few minutes worth. So merging. So this is an interesting idea, right? So this is some of the polar signals magic here. Like in addition to having the individual profiles, you can look at the aggregate over time, right?
Yeah, so I think in particular, it's cool that you pulled up the CPU one. If you click one individual one right now, we can see that it says it profiled over 30 seconds.
Yep.
Like it sampled over 30 seconds, right? And if you hit merge now, you can nicely see how it kind of takes all of the samples from all the profiles, and it now says like 5 minutes worth of samples are included in this result.
That's so sick. So, for example, here when we looked at the previous profile, can I just So this is like this looks like a GC cycle had just happened and basically nothing else. So this profile for this profile for our application like developer perspective is effectively useless. Like I would have just like run pprof again. But the fact that I can just say merge here and just take a look at everything over time, this is actually very useful because of course we still have the GC worker here. But then you'll see things like, for example, like the flates decompression. So the target scraper, so you can see like the actual like scrape loop running here. So you can tell your application code, clearly is doing other things, but it looks like the GC still is doing most of the work here as far as the CPU goes.
Yeah, I think this is so useful as like as a starting point of doing optimizations, right? Because basically, if you do the merge and something stands out in the merge, it means that this is something that is significant through the entire lifetime of your process or throughout the entire profiles that you're merging over, right? So it means that if you can get this down, you're going to definitely reduce the resource usage of your entire process, essentially, instead of just like something that may have happened momentarily.
Mm-hmm. So there's a question in chat. Can we browse source from this? I guess not. Would be awesome if standard lib could get source browsing right from this website. Yeah, but I think the problem is you would have different versions of the standard library, right? I guess there probably is some metadata that says this was Go 1.16 release, but I have no idea how the source code browsing works locally. It probably uses like your Go root and everything.
Yeah, I mean, there are definitely really cool opportunities to like integrate into like GitHub code spaces one day or something.
Yeah.
If we know the exact kind of source code version, and maybe even if it's open source or even if it's closed source, right? As long as we know where it is and what kind of commit it was, we should certainly be able to immediately jump to it.
Very cool. So as a Go developer, I find myself most often looking at the Alex and the heap, and then Alex profile and then heap profile. What's the I thought Alex was part of the heap profile.
Yeah, actually, this is just something that's still on our to-do list. Like you can, the only difference here is that they actually contain the same data, but um, you, it's just the default one that you're going to view when you click one. So you can
I
still
see.
click
Yeah.
and you see. So actually, this is kind of redundant right now.
Okay. Okay. And then the other one, so the Go routines, this is also something I've used as well in the past to find out where a whole bunch of Go routines are stuck. For example, if you're like leaking a Go routine, let's see here. So, runtime Go Park, that's good. That means that chances are pretty good you're not doing any crazy busy loops and in here. It's some run groups, nice little Peter Borgen stuff going on here.
Yeah.
HTTP2, cool. So actually, I'll be honest here. Like I've been using Go for a very long time, and I have found myself basically never using the blocking profile, like the thread creation. Have you run into any circumstances where those are useful for your work, Frederick?
Not so much.
Yeah.
The Go routine one certainly. Like it's very easy to accidentally leak Go routines.
Yep.
But thread create, I don't think I've ever really needed it. Yeah.
I guess thread creation would be like, for example, if you are let's take a look at the merge view really quick. Start template thread. Huh. Yeah, not a whole lot going on here. So I guess like thread creation would imply that perhaps you are using you're doing like IO in an inefficient way. So the runtime handles a lot of the IO for you in Go, like the runtime network polar and such does all these things like epoll, KQ, Windows IOCP, and everything behind the scenes. So you as a caller don't really have to care. Like, in fact, all of your IO is asynchronous in the background, and the Go runtime is coordinating it for you. But you, as a caller, just see my Go routine is blocked. So it actually provides a really nice user experience. But there's definitely a lot of tricky things going on. But yeah, I've never actually run into a scenario where I had to really dig into these profiles very much.
Yeah. There were a couple of comments in the chat that I think are worth highlighting.
Yeah.
So there was a comment, for example, that pprof doesn't include the source code. So that's true. It essentially only has kind of snippets and pointers. Let's leave it at that. It's essentially just metadata.
Yeah.
But the way that we could, for example, do this correlation of like jumping into source code is through the labels that we can attach to this data. And what Matt showed in the very beginning was that the service discovery parts and the configuration parts are actually almost one-to-one to what Prometheus does. And so we can actually add any sort of environment labels to this, and then we could do this kind of jump, right? So for example, when the way that we continuously profile all of our applications at Polar Signals is we label a bunch of like Kubernetes labels onto it so that we can search by namespace and by container, by pod, etc. And we could do the exact same thing for the like container image or stuff like that.
Mm-hmm. Absolutely.
So
I know that like Prometheus, for example, like all of the Kubernetes service discovery and stuff is like, very very mature and very well used. It's kind of funny because like I for a while kind of wanted to run Kubernetes here at home, but there's just no real need for my stuff. So that's kind of where I've settled on NixOS because it gives me kind of the declarative aspects of Kubernetes that I really wanted, but just without any having like I don't need to run a cluster of highly available things or it just doesn't matter for me.
no, I think that makes perfect sense.
Mm-hmm. Very cool. So I think probably something that'd be pretty cool is to set up different targets here. So for example, like I know, for example, like some of the services I have running, I'm pretty intimately familiar with like what's going on in those. So I think that could be pretty interesting to see perhaps what sorts of trends are revealed. So I think I'm going to add another target. But let's see here. So we'll copy all of this and we will add another target. So this would be 9107. Hang on a sec. So curl. No, that's not a shoot. I already forgot 9135. Nope. I forgot. I've been working on an application recently. Where does Corad live by default? I gotta look at my own website to remember what service or what port my own service runs on. 9430. 9430. Okay. So if we scrape 9430 on my core red instance on my router, we will actually see profiles coming in as well because I have pprof enabled there. And with that application, I'm very familiar with how it should look. So that could be pretty cool. And of course, we can add other targets as well, things like Prometheus exporters. But let's run that. And you mentioned this has like service discovery and everything. So I still use like the static Prometheus templating. I can actually pull that up. Let's see here. So I effectively have just like static scrape configs, but I've got kind of like a little bit of a DSL here that generates like certain metadata around them. But in my particular case, since everything is kind of defined in the same repository, I'm able to template this out pretty effectively. But that being said, I would really like to set up something like DNS service discovery because I think that would make my life a lot easier. I just haven't bothered yet, you know.
Yeah.
Cool. So we've restarted conprof and it's now scraping multiple targets. So we should start seeing profiles coming in for Corad, which I would know more about. Let's see here. So let's take a look at the heap profile search. Job equals conprof. Okay, so maybe it's not there quite yet.
You might want to enable debug logs. I'm not sure why, but there are no samples coming in anymore.
Okay. -- log.level debug, right?
Yeah.
On it. Switch. Oh, do I need the... Oh, whatever library that says supports both the equal syntax as well as the space syntax, right?
Yeah.
Okay. Yeah. I just saw that inconsistency and it's like, oh, maybe I messed that up, but... Large Data Bank asks in the chat, speaking of labels, is it possible to use pprof labels with this tool? Typical use cases are labeling samples with the endpoints that triggered them. I'm actually not familiar with pprof labels.
Yeah, I mean, we don't index them right now, so you can't search by them, but they show up just like always within the tooling. Yeah. So there's definitely more opportunity for us to make use of them. We just haven't much yet. In the very beginning, I talked a little bit about extracting metrics from individual profiles, and we're certainly looking at kind of making use of the label data in there because that way we can then do like aggregations over certain labels or stuff like that. And I think that is probably where labeling and pprof will come in super handy because you can then say, just like you said, we can do aggregations over all the certain customers or something if that's the label that you're attaching, right? Yeah.
Very cool. So I enabled debug logs here, and it looks like, something is happening, right? So I would imagine that perhaps we will see more samples now. So I'll go back to my top-level project and everything. Danger area. Nice red. Nice scary. Okay. Last hour. Sure. Show me all of my heap profiles, please. There we go. Okay, so now we're getting profiles from two different jobs here. So Core Red is something that I am familiar with. So I will be able to take a look here. Yeah, HTTP. Oh, looks like it's pretty much just allocating memory for HTTP stuff. Oops. Is this the in use? Let's take a look at allocated space. So over the whole time. So we got gzip. Yeah, Prometheus. It's so funny how, like, these daemons that sit around doing not a whole lot ends up being like the Prometheus instrumentation, like the gzip and everything takes up the majority of your memory consumption.
Yeah.
Yeah, so if we go over here, parsing netlink data, really? Interface, address table. Oh, yeah, I guess I do have to pull apart the net interfaces information here because I need to constantly be checking the states of the interface in order to determine if I should still be forwarding traffic. And if the router is forwarding traffic, I need to set certain flags, so I keep querying the kernel for this information. Okay, so we've got 3 profiles so far. Let's merge them all. I like this merge feature. This is sick. I'm a huge fan. I would expect to see... There we go. Yeah, I was going to say, I'd expect to see some of my own code in here. So, for example, this router advertisement. Yeah, so every time Prometheus comes by and scrapes things, we need to generate, actually, a router advertisement at that time because we export lots of parameters from that. So for example, like the current state of like, you know, the lifetime of the prefixes you're advertising, whether or not you have like the managed flag set for DHCP v6. So we export lots of information here because you can actually write alerts. So for example, I have found that for some reason my ISP will just stop sending me router advertisements, and I can actually watch for that now and like alert on the actual neighbor discovery traffic, which is pretty sick.
We've
Yep.
got another question in the chat.
Yeah.
Can you manually select which profiles get included in a merge? Yeah. So if Matt were to just hit search again here, you actually can kind of preview what you're going to merge. And so actually, what you've just been doing, Matt, was you merged all of the profiles from conprof as well as the other series that you were seeing here. So
Yeah.
what would be better here would be if you just clicked on one of the labels. And
So
then,
job equals. Yeah, I see.
that's it. And now you can just hit merge.
Oh, so we
And
were
you'll
actually
see.
merging from two different targets.
Yeah.
Interesting. Okay, yeah, so that was that makes sense now that I think about it, but as somebody who wasn't like thinking, I was just like, "Oh, I'll just let's see here." So yeah, heap job equals corrad. We got 5 profiles merge. Okay. Deflate writer. Yeah, of course. So primarily interesting. So yeah, it looks like the majority, it's kind of funny, the majority of the memory consumption is coming from conprof hitting this because this daemon doesn't need to do a whole lot. Like it kind of sets up and it sets some timers and is sending messages like, you know, 3 or 4 times a minute. It doesn't take much traffic to keep your IPv6 kind of up and running. So we're actually seeing a lot of the pprof calls in here, which is pretty entertaining. Yeah, so the multicast loop here, like this, we have a loop that will send out like an IPv6 router advertisement multicast. So this is only using 14.39% of my allocations, but the serve HTTP between the pprof profiling and the Prometheus instrumentation is using the rest, which is pretty entertaining. Cool. How about the CPU? Just out of curiosity here. So search last hour and merge these together. That feel when your profile takes more work than the program itself. Quantum effects, if you observe it. Yeah, it's true. Very true. And this isn't particularly CPU intensive. Yeah, so we're probably going to end up with mostly syscalls. So, runtime scheduling. So the Go routine scheduling within the runtime here is the majority of the 37.21%. Let's see here. And then we've got things like HTTP conserve, pprof profiles again, prom HTTP, so Prometheus pprof. Pretty neat. So yeah, I would have expected syscalls in here, but I guess this isn't doing that many system calls. Like it's only doing like 3 or 4 a minute, so it's not that big of a deal.
Yeah, we've often seen that people kind of already have a vague idea of what they want to improve, right? So one of the things that we're going to be looking into is how you can kind of hide all the noise, let's say, like the Prometheus metrics, the profiling stuff itself, so that you can truly only focus on the things that matter to you.
Yeah, totally. I'm trying to think here if I have a program that would be more interesting, like a lot more CPU use. Perhaps so Core DNS comes to mind. I know Core DNS like is actively doing lots of things on my network, but I don't actually know if Core DNS exposes pprof by default. It might though, so I suppose we can find out. So we know conprof is running, and that's fine. Let's see here. So where does Core DNS live? 9153. That makes sense. So curl. Of course, it's got the metrics endpoint, but does it have debug pprof enabled? I don't actually know. It does not. That is sad. Maybe there's an option for that. What else am I... Prometheus. I guess Prometheus would be something we could look at, because Prometheus is definitely busy.
Yeah.
So that would be 9090, right? Does Prometheus expose pprof by default?
Yeah.
It's not running on my router. It's running localhost. It is. Sweet. Okay, so we'll add Prometheus as a target. That will be interesting. So It's on localhost 2. Update that. Let's see here. Jimmy says, after profiling one of my programs, I discovered I had to cache the clock to avoid the get time of day VDSO overhead. Interesting. I thought the VDSO was like already a lot more lightweight. So you're really calling out to the clock that often, Jimmy? That's wild. Okay. So now we should have a scrape target for Prometheus. So we probably got to wait for it to populate as well. Looks like we've got another question for you. Are you able to show diffs between two different runs, e.g., two different versions of the same product, and visualize the improvements?
Yeah, absolutely. If you go back to the polar signals, you can see here, for example, if you just hit search one more time.
Yep.
We've got profile right now. Maybe switch over to heap.
Okay.
So that tends to be more interesting. And you select one of those, and then you hit compare. And now you're essentially selecting the one that you're comparing with, right?
Oh, so you could, for example, like you could set it up so that the instance running on your production server versus your staging server, and then compare the two.
Right, or different versions, right? Like you've done a change, and you want to verify that that change has actually had the effect that you wanted, or you're investigating a regression and you want to compare like the previous version to the current version.
Very cool. So of course, like comparing two different applications here is not really helpful. So I'm only running, actually I am running 2 instances of that, but I don't think they're gonna be doing a whole lot differently. I could add another target just for fun here. So in addition to,
you could also actually compare from the same process, right? Like they're taken at different times. So it could be that there are slightly different nuances of the process.
So what selectors should I use here? Just the same selectors as before?
Just the same one.
Okay.
Same one, yeah.
Sure. And then search.
Yeah. It needs quotes.
Right. So if I click any one of these now, we're going to compare the two.
You'll first see the one that you're clicking, and then you can say that you want to compare with this one. So if you hit compare now again, you can see that up there.
So we're comparing
We're
comparing the 5 p.m. profile, the 5 p.m. to the 4:59.
Exactly.
Interesting. And in this particular case, it looks like it's better, but perhaps it wasn't doing like Prometheus scrape at that time or something.
Yeah. And this then becomes super interesting when you compare to merges, right? Like as I said, when you investigate a performance regression, or you're looking to see if the change that you've done has had the effect that you wanted, then you can just compare 2 merges with each other, right? And that way you have a real representation of like the entire lifetime of that process, and not just this one moment in time.
Very cool. So I think now we should be ingesting Prometheus profiles as well, which could be pretty interesting to look at. So let's take a look at the Prometheus CPU profiles, right? So job equals Prometheus. Excellent. And Prometheus is going to be a lot more busy than, for example, my stuff. So, scrape loop. So HTTP requests reaching out. Snappy compression, it looks like.
Yeah.
Appending to the TSDB. Oh, Snappy has AMD 64 assembly, huh? That's cool. And then garbage collector. So yeah, it looks like even Prometheus is not that busy in this particular case. But that being said, if we compare it with perhaps another job equals Prometheus. Jimmy complains in chat, you just had to inherit an awful PromQL style syntax, huh? It's not that bad.
We're still kind of working on some more autocomplete features. As you can see, like Matt was still typing out the individual label. Actually, label names are already auto-completed, but label values aren't yet. And we're still working out that all of that is kind of a little bit easier to write, and you don't have to learn an entire language, so that it just comes kind of naturally.
Fair enough. So I just did a quick comparison here with the Prometheus stuff, and it looks like, let's see here. So there was less time taken in the scrape loop, which means probably just not scraping as many targets or something there. Yeah, this would be pretty interesting if we had like two very different versions. So for example, like I wish I had this at work now because I just went through like a big rewrite of an app. Well, not a rewrite, but updating a library that was like 2 years old to a newer version of a library, and we noticed a pretty significant drop in the memory consumption actually. And it would have been interesting to take a look at the profiles of the memory in production versus the memory now to see what exactly has changed, because I frankly have no idea. Like I assume probably the library just got more efficient, but I don't actually have that. I just had the Prometheus, like, you know, something changed versus like, oh, this function is now using 100% less memory, you know?
Let's get it to into production and testing.
Yeah. I'll see what I can do, but that's a conversation that you'd have to have with someone above my pay grade. But definitely continuous profiling. I can see this being something I would like to. I mean, I'm definitely going to have this deployed here, but it's something that I could see myself wanting in a production environment, certainly, because, you know, I do lots of ad hoc pprof profiling, but as far as being able to do like these comparisons and like merging the profiles, that's incredibly useful. That's something that I really like.
Jimmy's actually asking, is there a plan to address profiling only a portion of pods in the deployment? So actually, this does work already. It's a little bit more verbose in terms of the configuration that you need to write, but you can already say that you want to only scrape like 1/10 of your infrastructure or stuff like that. So that does already work. And one of the other things that we haven't looked at, maybe I don't know if you even have a case like that in your home lab, but you can do the merge not just over a single process, but over your entire fleet essentially,
Right.
like over your entire fleet of processes. And you could, for example, say there's this one process that for whatever reason is an outlier, right? You could say, okay, compare all of my other processes to this one process that is an outlier for whatever reason.
Mm-hmm.
And then immediately it can tell you these are the portions of memory that are, or portions of your code that are actually using this additional memory.
Interesting. Yeah, I guess it's kind of funny. There was one point where I used to run like, you know, like web servers at my house, but I don't do that anymore because I think it's, you know, everybody, you do you Twitch chat, but I'm not gonna run a web server or a mail server or that kind of stuff at my house because I would like to sleep at night and not you know, like
Yeah.
I run stuff that has a very easy SLA of, you know, fix it, whatever, it works. I do have, I guess the one thing I do have is I have a Plex server that I share with some family and stuff, but even then, like I don't think Plex exposes Prometheus. It does not. No, I know there's things that can though, or profiles. Actually, Plex is Java too, so sad. Yet you run your router infra. Yeah, I mean it works just fine. Like the thing is like, you know, I actually understand my router better than I understand like the Ubiquity router or the you know, any Netgear bullshit. Like I think that's a good trade-off, but I think running your own email server at your house, like there's no trade-off to be made there. I think that's just a horrible idea. You do you.
Jimmy was also asking, does that let me avoid setting up the profile in main so that I have absolutely no overhead rather than just not being scraped? So actually, there's no overhead happening if you just have the HTTP endpoints exposed. Yeah, so the pprof start CPU profile, that literally only happens when the HTTP endpoint is hit. So you actually have zero overhead.
Yeah, it's kind of funny because I've seen people use the pprof start CPU profile, but as far as I know, that's only really useful for like short-lived like CLI programs and stuff, right? Like I always just use the HTTP endpoints in my own applications because everything I'm writing is, you know, going to be run continuously on some schedule, serving requests, whatever. So I actually have never really found a reason to use the short-lived stuff unless you're running like a benchmark, maybe, you know.
Yeah, that's what I was just gonna say. That's what I tend to use it for. If there's a very specific thing like in my benchmark that I want to profile, that's when I use it. But other than that, agreed.
Right. By the way, I appreciated in the presentation how you discourage the use of the global pprof HTTP mux, because that drives me crazy that anytime anybody uses the global HTTP mux in general. So for those who are familiar with Go, let's see here. So Golang, not HTTP. I'm gonna complain really quick because I hate this. Let's see. So if you do, for example, http.handle, you are modifying global state, the default serve mux, and like this is a thing you can do, and it's very it's convenient. But if you do this, you can have unexpected consequences. So the problem is here if you do net http pprof, right? If
Yeah.
you underscore import this package and use the default mux, you are exporting all of your pprof data to the global mux. And this is a horrible idea because what's going to happen is you're going to listen on port 80 and suddenly your pprof is exposed to the internet and people are going to do all kinds of funny things to you. And this is bad. Don't ever do this. Like, you really do want to initialize all of the endpoints individually instead. And I'm glad
and
that
it's really not.
Yeah.
Sorry, go ahead. It's really not that much, right? Like we see 3 lines here, but like adding the handles to each like each individual one is like 5 or 6 lines of code, right? So
Yeah.
go the extra 4 lines of code.
I personally hope that if we ever get a net HTTP v2, that it totally eliminates the default serve mux. Like, I think that it's not worth the trouble. And I would rather, in my mind, like, this should panic. Like, you're trying to serve off of a nil, like, this should just panic and this should be discouraged, And when I see people carrying this pattern because, oh, the standard library does it, like, you got to realize that the Go standard library is amazing, of course, but the expectations of the community and some of the code quality things like the ideas we have changed in the past 10 years, right? And as a result, you are going to get yourself in trouble if you cargo cult some of these patterns like underscore magic imports and global state. Like, this is too clever. You are too clever for your own good,
Yeah. Jimmy just mentioned as well, this is very old stuff.
Yeah.
That has remained as part of Go 1, I guess.
Yep.
Like,
yeah. So it is what it is, but don't do it. So cool. So we got 3 different targets going on right now. I'm trying to think. Honestly, I feel like there's just nothing I'm really running that is super, I guess perhaps like, super high traffic or super interesting. I'm trying to think if there's like a use case here. I mean, of course, like I can't, as much as I want to use this in like work infrastructure, I can't like stream that or anything, So I would have to play and everything. There are use cases at work where I could see continuously profiling being very useful. For my home stuff, definitely like this is neat to look at, but since I'm not deploying things that frequently and I'm not serving that much traffic, perhaps it's more limited, than like my Prometheus infrastructure.
Yeah, that makes sense.
So is there anything else that like you want to show me, or is there anything interesting I could do? Or perhaps like, do you want to share your screen and show some stuff?
I could share maybe one very small thing that we've been working on recently.
Sure, if you want to do that. Let's see. I'm trying to think of how. So I think if you screen share, as long as I have the Zoom window here, we'll get it. So one sec, chat. I'm going to hide this really quick so we can make sure that we don't share anything we shouldn't. There we go. Okay, you can still hear Frederick. Okay, I'm gonna stop sharing my screen really quick, and I will let you share if you are going to do that.
All right. Whoops.
And I will full screen you once we're ready to go.
So this is something that is not live yet.
Are you sorry? Are you okay sharing this on Twitch?
Oh yeah, absolutely.
Okay, here we go. Done. Yeah.
All right. So what you're seeing right now is like the normal Prometheus UI, and this is kind of something that we're working on right now, where you can essentially what we're doing is we extract metrics out of these profiles. So essentially, that top table that Matt was showing earlier, we convert that to metrics for every single profile that we've collected. And that way we can kind of see these patterns as kind of time series, right? Time series are just so much better at showing you a lot of numbers in one picture. right? So if you, the idea here is, for example, if you have a memory leak, this should very clearly show an upward trend in some part of your code. And that way you should be able to pinpoint really fast what the code is that you should be looking at right away, right? Instead of just having this one memory profile that you took and had a look at, right? Here you should be able to see a trend. That's kind of the idea of something that we're working on right now. Not exactly sure how much longer it's going to take for us to kind of ship this into production, but the kind of fundamentals are already working, so that's pretty neat, I think.
Yeah, this is really cool. So I know you talked about this in your presentation as well. We should find a link to that presentation and put it in the chat. Frederick gave an overview of, I guess, conprof continuous profiling as well as like polar signals and some of the stuff they're doing at the CNCF Berlin meetup a couple weeks ago, and I thought that was a very interesting presentation as well. So this is, so I guess the first thing I notice here, the name label appears to have what looks like a Go heap memory address as well as like line numbers. So is there like a cardinality concern here?
So this only looks like Prometheus. It's not. So essentially, what we're doing here is we extract these at query time from the profiles.
Mm-hmm.
So there's actually no cardinality concern because we don't index each of these.
Oh.
All of this happens at query time. Only the like instance and job label are what we took from the profile series. All the other ones happen are generated at query time.
Very cool. Okay.
So we're not actually ever going to have that kind of problem. The difficulty obviously then is we can only we have to select the profiles first, and then we like if we were to like filter this down further, we could only do that once we've generated the metrics, right? But it's much better than having to index all of them. Yeah.
Yeah, certainly. Yeah, very cool. I look forward to playing with this for sure. Like this will be very useful. So you can actually tell like, you know, the trend over time of a particular function, like its heap usage or its CPU usage. Like that's insane.
Yeah, that's the idea.
Jimmy says it's like Presto for Prometheus. I feel like I've heard of Presto, but I'm not actually familiar with what it is.
It's this. I would probably misrepresent it as well, but I think you can kind of have whatever data sources you want and do some sort of SQL language on top of that. I think it's some big data tool.
It's like Grafana for SQL, says Matthias. Huh. Okay.
Okay.
Cool.
Yeah, but this is just what I wanted to share. That's pretty much it.
Cool.
I'm gonna stop sharing my screen here.
Yep. 1 sec. I'll get back to where we were. Exit full screen. Uh-oh. Zoom is let's see here. So chat, it's kind of funny here running Zoom and OBS at the same time. They don't really want to get along very well. So that's it's a bit of a challenge. Suddenly I have what appears to be a different window for Frederick here, and I'm not actually sure why. What did I do? What did I do differently? Oh, it's because I'm not sharing my screen anymore. Okay, right. So I can go back to where we were. Share desktop. Okay. I think we're back. Yeah, there we go. I got to get rid of the Zoom toolbar again, but cool. Very fun. So is there anything else we want to go over? I'm trying to think if there's anything else that I could. Yeah, I guess the problem is here is that like I've got this set up and I've got this working, but like I said, like by and large, my home lab stuff is not that interesting because it's not serving real production traffic, right? Like it's keeping my IPv6 running. It is gathering metrics from tens of targets. You know, there's not that much going on compared to like a production system. You know. Oops.
Yeah, that makes sense.
Could look at a couple Go routine things. This could be interesting. So, for example, Go routines. Lots of sleeping Go routines in this, I would expect. Oops. JavaScript stuck. Let's see. 55 Go routines parked. Yeah, it sounds about right. You want to conprof cockroach DB? Yeah, that would be sick. So Jordan, I would love to see you set this up because I think this would be really interesting because you clearly uh, Jordan working on cockroach DB is a very serious real application that does lots of production traffic and stuff. That would be pretty cool. And Frederick says in chat, send me a message on Twitter. We'll get you beta access. Yeah, you guys totally should. That'd be sick. Also, Jimmy says use Discord. You do pair programming streams, and Discord's much better than Zoom. Yeah, we should. I mean, the thing is that like, anytime you're gonna do this with like OBS and whatever else, it's just gonna be a pain in the ass. Like any system is. The thing that Michael Stoppelberg and I did with like the the G streamer magic, like that was incredibly cool, but it was just difficult to set up. Like every single one of these is gonna have some trade offs, and Zoom is just pretty easy considering I'm just driving mostly. What are you gonna do? But yeah, cool. I guess I don't really have a whole lot else I wanted to. I guess I don't really have a whole lot else I wanted to cover. Do we have anything else we want to talk about, or?
I mean, if people are interested, I can kind of. I'm not sure we still have this situation, but recently we actually did have kind of a memory leak, and it was cool because we kind of could use our own product, right?
Yeah.
And yeah, if people are interested, I think it should still be there because it's kind of out of our control. And I could show how it would work.
Sure. Yeah, if you want to do that. Do you want to share again?
Yeah, I can share again.
Okay, one sec. Okay, let's get that set up. Yeah, it sounds like fun. Like being able to see your product like solve real production problems for your company is that's sick,
Yeah.
One sec. I will. Now you're going to share. I'm going to go full screen, and then I'm going to get rid of my pane, and then I will share my desktop again whenever we're ready to go.
I guess we're gonna start with. Let me pull up some dashboards first.
Yeah, sure. Jimmy uses Teammate, which is Tmux over a network socket. When you pair a program, it works like black magic. That's pretty cool. So back in the day, I used to use Vim. I was never very good at it, and when I got my Kinesis, I became literally incapable of using Vim. Like all of the muscle memory went away, and I decided to try VS Code, and I have not gone back since to Vim. So maybe if I was a more top tier programmer, I could handle such things, but I will enjoy being average. It only works because you and Barrick have very similar Vim configs. Yeah, that makes sense. Yeah, I guess as soon as you get into somebody else's like Vim instance that's like highly customized, that would be like crazy, And it's so funny because like I feel like I used to spend a bunch of time. I feel like I used to spend a bunch of time like working on customizing my configs for everything, but I've come to realize that I prefer generally just a more stock experience because as soon as you highly customize it, it becomes impossible to like keep track of everything I've done. Like my Vim config was just a total mess of plugins and everything else, and it was just a total pain. But oh, cool. Looks like we're ready to go. Should I move this over to the stream? Frederick's going through some dashboards at the moment. I don't want to share too early, but
that's okay. So we can drill down into this, and then we should be good.
Cool. You ready for me to?
Yeah.
All right. Here we go.
So this is actually our continuous profiling infrastructure, and we've got this component called the router that kind of does the consistent hashing and then forwarding all of this data to the respective kind of storage backends. And you know what? I actually pulled up the wrong dashboard, but that's okay. We want to have a look at the entire workload at once. And we want to go to continuous profiling. And
see, chat, this is what Prometheus dashboards look like when somebody who actually knows what they're doing builds them. Mine are like fine, but this has all these like crazy drill down, these selectors, all the aggregations. Like, it's pretty sick.
So when we look at a like 7-day window, I think this should still,
Oh yeah.
You can see that this has a beautiful memory leak somewhere in here. Um, so we can go a bit closer to this and see what our timestamp is here. And what I was talking about earlier as well, one of the things that we're working on is kind of displaying aggregate metrics as well, so that I don't have to do what I'm doing right now and find the timestamp first, so that you can then go to continuous profiling and find it. We're gonna kind of integrate this kind of functionality directly into polar signals. But right now, so this is um, the 26th of February at 9 a.m. UTC. And what we were looking at before, when did this process start approximately? Let's see. So somewhere here, the memory leak started. So on the 24th. 24th to, because these are the two that we're going to want to compare. Okay, so let's jump over to the other tab then.
So memory leaks in Go, I find, are most often caused by kind of like a stranded Go routine that has some memory still in use, or maybe like an open file descriptor. So I'm curious to hear, I guess, the root cause of this as well.
Yeah, it'll be pretty obvious once we pull it up.
Oh, okay, yeah, that's even better.
So we've got continuous profiling, and then the pod was something route-like. And we've got our heap profile perfect. So that was the somewhere around the 26th. And here we can nicely see these died and these were spun up again.
Yeah.
So let's take that one, and then we want to compare.
And this is awesome because you had the profile right before the process was out of memory, so you can tell immediately like what has the most in use space here, I would assume.
Exactly. So we can again. And then somewhere on the 22nd, I believe, it started. Oops.
Chat says it's always Go routine leaks, and then Go routine goes off to the bathroom to take a quick memory leak. Yeah, pretty much.
I mistyped something here.
One of my first experiences with a Go routine leak was my first Go project. I was, like anybody else, spinning up way too many Go routines channels, trying to do everything, async, because async is faster, right? And I looked at the number of Go routines in my application. It's like, wow, 50,000, 100,000, 150. And it's like, man, my program must be doing a ton of work. And then now, of course, you realize that, like, oh, you got a Go routine leak, you dummy. Like, you're all waiting on a channel that will never be sent on or something. It's like, it's just the silliest thing,
So we chose route. Let's make sure that we compare it to the same one.
Yep.
That's actually this one. No, it's not. It's this one. So let's take it from where it started, and we can see quite clearly, oops, it's the OpenTelemetry global tracer. So
yeah.
Once again, global's biting us. Yeah. So this is actually a bug that we already filed on the OpenTelemetry project, and there's nothing wrong about the OpenTelemetry project per se, right? Like, it's just these things happen. But the nice thing was we could just take these two timestamps, right, and compare them, and we could immediately see this is where the absolute overwhelming majority of our memory is spent, which is almost 60%.
Huh. So this was not a bug in, like, this was not a. Did you run into like some kind of case where the OpenTelemetry client perhaps was like stuck sending traces somewhere, or?
We're still working with the OpenTelemetry folks. What's actually happening? It seems like there's something about this global tracer that just never frees something.
I see.
Like, yeah.
I actually ran into something at work the other day. So we're writing some code that inserts a a large number of netlink messages into the kernel. So for example, I have a slice of like anywhere between 500,000 and a million netlink messages, and what I was doing is I was iterating through it like 1,000 messages at a time and just reslicing forward. But the thing is even if you reslice a slice forward, like a shifting window, I think that entire backing array, until it has, no more references, cannot be cleared. So it's not like it can clear the previous batches. So once I go through the whole thing, I have to make sure that I nil it immediately, so that way the slice header goes away, and as a result, the runtime's like, hey, I can reclaim this entire array. But I was doing a little bit of experimentation beforehand, and I think I was like, oh, wow, I'm stranding a lot of memory. I need to be careful.
Yeah, it can happen easily.
Mm-hmm.
Yeah, so that's what I want to share.
Very cool.
I'm gonna stop sharing my screen here.
Yep.
But yeah, this took us like a minute or two, right, to pull up the right data that used to take us like maybe days of reproducing the right situation, right?
Yeah, totally. Yeah, very cool stuff. So I think I'm going to see if we can get conprof and such deployed at work, and perhaps look into something like this. But that being said, it's definitely a tougher lift at work than it is for me here at home. But this is something I would absolutely use.
Awesome, let's do it.
Cool. Well, I think, let's see here. Yeah, I don't think I really have anything else I want to share a look at this point. Should we perhaps sign off?
Yeah, sounds good.
Unless folks in chat have any questions, just do a little bit of a more abbreviated stream today. I guess we'll give folks a minute or two to ask, but yeah, this is pretty neat. I look forward to seeing like what sorts of other like features you can develop here. So for example, the idea, like understanding that the pprof profiles can be transformed into like Prometheus metrics is like, I guess intuitively like makes sense, but it's something I had like never even like considered before as like a possibility. So the fact that you're thinking about these things and like, going to make a product that exposes these things in nice ways is awesome,
Yeah, I mean, there's just so much cool things that you can start to do when you have data, right?
Yep.
And like this goes to show that just having data allows for so many more cool workflows. Jimmy was asking one more time, when will you support Python? So Python actually already has pprof libraries, but we have no Python code, and we haven't worked with anyone so far with Python. But this is totally something that should be doable for us. And maybe Jimmy, you and us can work together on Python support, so that maybe we could get you to use it at Offdeed as well. Hopefully I pronounced the company correctly.
Absolutely. Matthias has mentioned a couple times that there is a Discord, so come to the Discord to continue chatting. There's conprof there too. I could always use another Discord, why not? So I will make sure I check that out as well. Let's see here. Would you rather fight 100 duck-sized horses or one horse-sized duck? It's kind of funny. I feel like I should have had an answer for that prepared for a long time now, but I don't know. That's a tough question. Cool. Well, thanks everybody. This has been a blast. Thank you so much, Frederick, for stopping by. This has been great. We will put this up on YouTube as well, so you can show folks, what a clueless user does with your product, and you can look at this later and realize like, oh, maybe we should make this little change here or there or whatever else. I'm always happy to give feedback as well. Yeah, this has been a total blast, so thank you for coming on.
Thank you so much for having me.
Alrighty, I will see you all later. See you later, Twitch chat. Bye now.